looked at what is fiber optics, what is its basic principle, total internal reflection. We derived something called the numerical aperture, and then we looked at what are the problems involved, like what causes loss of signal. So now we're going to look at the most basic purpose of learning any new concept, which is the applications. So we're going to see where fiber optics are used. There are two major applications. One is telecommunications and the other is sensors. So in this PPT we'll be looking at telecommunication, how it is used in your Wi-Fi networks and all that, and we'll also be looking at light sources and detectors a little bit. In the next PPT we'll look at fiber optic sensors and then we'll wind up. So to quick overview of the characteristics of optical fiber: small size, lightweight, low attenuation, high bandwidth. High bandwidth meaning a large amount of information can be modulated onto a single beam of light. Secure transmission, capability to withstand high temperature, and EMI free meaning electromagnetic interference free. So neither electricity nor magnetic field is going to affect your fiber optic cable. And these are some applications: telecommunication, defense, remote monitoring, sensors, medical field. And non-linear studies is your predicting earthquakes, volcanoes and all that. So that is that. So telecommunication block diagram. So this diagram basically explains how fiber optic cables are used in transmitting signals for telecommunication purposes. So we start with the signals which are present either as analog signals or digital signals. They are fed into a transmitter. The transmitter first contains a drive circuit. This drive circuit takes these analog or digital signals and feeds them into a light source. So all this while we've been talking about signal being given in the form of light, right? So I kept saying you shine a light wave, you shine a light wave, but you already have some electrical or some binary data or something which is what you want to transmit. So how does that conversion from whatever you have to optical signals happen? That happens inside this drive circuit. We're not going to go into the technicalities of that, it's beyond the scope of the chapter. Just understand that the transmitter contains a light source, which is an LED or a laser diode, and a drive circuit. The drive circuit is responsible for picking up these signals and feeding them into the light source in the appropriate manner. That is then connected to optical cables. A connector is used for connecting a device to the cable. Splicer is used for connecting two cables themselves. As in when you're traveling over a long distance, like I said, for example Chennai to Rajasthan, it's not possible to do it within one fiber. So you take multiple fibers and you join them. That joining equipment is called splicer. And coupler or splitter is used to split the signal into two paths. So let's say you have a point where the road forks into two and you want to lay a network for each path. So you had one path so far. At the point where it's splitting into two, you use a coupler to split the signal into two parts. And then it goes to a repeater. A repeater does a job which is similar to an amplifier, as in it takes the signals and strengthens it again or sort of magnifies it again and sends it. So what it does is the signal that comes to the repeater is taken up by a receiving transducer, and then some electronics are present inside which are responsible for the amplification, and then it goes out through a transmitting transducer. Again it passes through your optical fibers. Amplifier does almost the same job as a repeater, and finally after traveling to the destination it is taken up by a receiver. The receiver, there is a detector which is a photodiode, pin diode or APD diode. We will be looking at these detectors in detail in a while. So the detector takes these light signals and sends them to the amplifier. The amplifier magnifies them again, and then the restorer converts these back from light to analog or digital signals. So this is how fiber optic communication happens. Quick recap: your signals are taken, the drive circuit inside the transmitter converts them into light signals. They travel through the optical fiber. Splicer is just used to connect two fibers together. Coupler or splitter to separate the fiber into the optical cable into two parts if necessary. Repeater takes the signal, amplifies it and sends it out. Amplifier also does more or less the same job. Finally, at the receiving end, your signal is detected, amplified and converted back to analog or digital.